may naturally develop, and some oil could simply be collected from seepage or ponds. Historically, we know the tales of eternal fires where oil and gas seeps ignited and burned. One example is the site where the famous Oracle of Delphi was built around 1000 BC. Written sources from 500 BC describe how the Chinese used natural gas to boil water. It was not until 1859 that Colonel Edwin Drake drilled the first successful oil well, with the sole purpose of finding oil. The Drake well was located in the middle of quiet farm country in northwestern Pennsylvania, and sparked the international search for an industrial use for petroleum. Photo: Drake Well Museum Collection, Titusville, Pennsylvania. These wells were shallow by modern standards, often less than 50 meters deep, but they produced large quantities of oil. In this picture of the Terre Farm, Oil Creek Valley, the Phillips well on the right initially produced 4,002 barrels per day in October 1861, and the Woodford well on the left came in at 1,500 barrels per day in July 1862. The oil was collected in the wooden tank pictured in the foreground. As you will no doubt notice, there are many different sized barrels in the background. At this time, barrel size had not been standardized, which made statements like oil is selling at $5 per barrel very confusing. Today a barrel is 159 liters. See units on page 141. But even in those days, overproduction was something to be avoided. When the Empire well was completed in September 1861, it produced 3,000 barrels per day, flooding the market, and the price of oil plummeted to 10 cents a barrel. In some ways, we see the same effect today. When new shale gas fields in the U.S. are constrained by the capacity of the existing oil and gas pipeline network, it results in bottlenecks and low prices at the production site. Soon, oil had replaced most other fuels for motorized transport. The automobile industry developed at the end of the 19th century, and quickly adopted oil as fuel. Gasoline engines were essential for designing successful aircraft. Ships driven by oil could move up to twice as fast as their coal-powered counterparts, a vital military advantage. Gas was burned off or left in the ground. Despite attempts at gas transportation as far back as 1821, it was not until after World War II that welding techniques, pipe rolling, and metallurgical advances allowed for the construction of reliable long-distance pipelines, creating a natural gas industry boom. At the same time, the petrochemical industry with its new plastic materials quickly increased production. Even now, gas production is gaining market share as liquefied natural gas, LNG, provides an economical way of transporting gas from even the remotest sites. With the appearance of automobiles and more advanced consumers, it was necessary to improve and standardize the marketable products. Refining was necessary to divide the crude in fractions that could be blended to precise specifications. As value shifted from refining to upstream production, it became even more essential for refineries to increase high-value fuel yield from a variety of crudes. From 10-40% gasoline for crude a century ago, a modern refinery can get up to 70% gasoline from the same quality crude through a variety of advanced reforming and cracking processes. Chemicals derived from petroleum or natural gas, petrochemicals, are an essential part of the chemical industry today. Petrochemistry is a fairly young industry. It only started to grow in the 1940s, more than 80 years after the drilling of the first commercial oil well. During World War II, the demand for synthetic materials to replace costly and sometimes less efficient products caused the petrochemical industry to develop into a major player in modern economy and society. Before then, it was a tentative, experimental sector, starting with basic materials. Synthetic rubbers in the 1900s, bakelite, the first petrochemical-derived plastic. In 1907, first petrochemical solvents in the 1920s, polystyrene in the 1930s, and it then moved to an incredible variety of areas: household goods, kitchen appliances, textiles, furniture, medicine, heart pacemakers, transfusion bags, leisure, running shoes, computers, highly specialized fields like archaeology and crime detection with oil prices of $100 a barrel or more. Even more difficult to access sources have become economically viable. Such sources include tar sands in Venezuela and Canada, shale oil and gas in the U.S. and developing elsewhere, coal bed methane and synthetic diesel, syndiesel, from natural gas, and biodiesel and bioethanol from biological sources have seen a dramatic increase over the last 10 years. These sources may eventually more than triple the potential reserves of hydrocarbon fuels. Beyond that, there are even more exotic sources, such as methane hydrates, that some experts claim can double available resources once more. With increasing consumption and ever-increasing conventional and unconventional resources, the challenge becomes not one of availability, but of sustainable use of fossil fuels in the face of rising environmental impacts that range from local pollution to global climate effects. 4.2 Facilities and processes. The oil and gas industry facilities and systems are broadly defined, according to their use in the oil and gas industry production stream. Exploration includes prospecting, seismic and drilling activities that take place before the development of a field is finally decided. Upstream typically refers to all facilities for production and stabilization of oil and gas. The reservoir and drilling community often uses upstream for the wellhead, well, completion and reservoir only, and downstream of the wellhead as production or processing. Exploration and upstream production together is referred to as E&P. Midstream broadly defined as gas treatment, LNG production and regasification plants, and oil and gas pipeline systems. Refining, where oil and condensates are processed into marketable products with defined specifications such as gasoline, diesel or feeds. Chemical industry. Refinery of sites. Storage and distribution terminals are in this segment, or may be part of a separate distributions operation. Petrochemical. These products are chemical products where the main feedstock is hydrocarbons. Examples are plastics, fertilizer and a wide range of industrial chemicals. 2.1 Exploration. In the past, surface features such as tar seeps or gas pockmarks provided initial clues to the location of shallow hydrocarbon deposits. Today, a series of surveys, starting with broad geological mapping through increasingly advanced methods such as passive seismic, reflective seismic, gravity surveys, give data to sophisticated analysis tools that identify potential hydrocarbon-bearing rock as prospects. Chart. Norwegian Petroleum Directorate. Barents Sea. 5. An offshore well typically costs $30 million, with most falling in the $10 to $100 million range. Rig leases are typically $200,000, $700,000 per day. The average U.S. onshore well costs about $4 million, as many have much lower production capacity. Smaller companies exploring marginal onshore fields may drill a shallow well for as little as $100,000. Means that oil companies spend much time on analysis models of good exploration data, and will only drill when models give a good indication of source rock and probability of finding oil or gas. The first wells in a region are called wildcats because little may be known about potential dangers, such as the downhole pressures that will be encountered, and therefore require particular care and attention to safety equipment. If a find, strike, penetration, is made, additional reservoir characterization such as production testing, appraisal wells, etc., are needed to determine the size and production capacity of the reservoir in order to justify a development decision. 2.2 Production. This illustration gives an overview of typical oil and gas production facilities. Figure 1. Oil and gas production facilities. 6. Although there is a wide range of sizes and layouts, most production facilities have many of the same processing systems shown in this simplified overview. Figure 2. Oil and gas production overview. Production wellheads. Production and test manifolds. O-stroke test separator. Production separators. 1-stage 2-stage water treatment. Gas compressors. LPHP metering and storage. Pig launcher. Gas meter. Oil meter. Gas pipeline. Oil storage. Crude pump. Pig launcher. Oil pipeline. Tanker loading. Injection wells. Injection manifold. Water injection pump. Gas injection compressor. Utility systems. Selected. Power generation instrument. Air potable water. Firefighting systems. HVAC. Export. Drilling. Mud and cementing. 7. Today, oil and gas is produced in almost every part of the world, from the small 100 barrels a day private wells to the large bore 4,000 barrels a day wells, in shallow 20-meter deep reservoirs to 3,000-meter deep wells in more than 2,000 meters of water, in $100,000 onshore wells and $10 billion offshore developments. Despite this range, many parts of the process are quite similar in principle. At the left side, we find the wellheads. They feed into production and test manifolds. In distributed production, this is called the gathering system. The remainder of the diagram is the actual process, often called the gas-oil separation plant, GOSP. While there are oil or gas-only installations, more often the well stream will consist of a full range of hydrocarbons from gas, methane, butane, propane, etc., condensates, medium-density hydrocarbons, to crude oil. With this well flow, we also get a variety of unwanted components, such as water, carbon dioxide, salts, sulfur and sand. The purpose of the GOSP is to process the well flow into clean, marketable products, oil, natural gas or condensates. Also included are a number of utility systems, which are not part of the actual process but provide energy, water, air or some other utility to the plant too. 2. 1. Onshore production is economically viable from a few dozen barrels of oil a day and upward. Oil and gas is produced from several million wells worldwide. In particular, a gas gathering network can become very large, with production from thousands of wells, several hundred miles apart, feeding through a gathering network into a processing plant. This picture shows a well, equipped with a sucker rod pump, donkey pump, often associated with onshore oil production. However, as we shall see later, there are many other ways of extracting oil from a non-free-flowing well. For the smallest reservoirs, oil is simply collected in a holding tank and picked up at regular intervals by tanker truck or railcar to be processed at a refinery. Onshore wells in oil-rich areas are also high-capacity wells producing thousands of barrels per day, connected to a 1 million barrel or more per 8-day GOSP. Product is sent from the plant by pipeline or tankers. The production may come from many different license owners, so metering of individual well streams into the gathering network are important tasks. Unconventional plays target very heavy crude and tar sands that became economically extractable with higher prices and new technology. Heavy crude may need heating and diluents to be extracted. Tar sands have lost their volatile compounds and are strip mined or can be extracted with steam. It must be further processed to separate bitumen from the sand. Since about 2007, drilling technology and fracturing of the reservoir have allowed shale gas and liquids to be produced in increasing volumes. This allows the U.S. in particular to reduce dependence on hydrocarbon imports. Canada, China, Argentina, Russia, Mexico and Australia also rank among the top unconventional plays. These unconventional reserves may contain more 2-3 inches times the hydrocarbons found in conventional reservoirs. These pictures show the Syncrude Mildred plant at Athabasca, Canada. Photo, GDFL Jamitsky Wikimedia and the Marcellus Shale in Pennsylvania. Photo, GDFL Rurfish Wikimedia 2 offshore. A whole range of different structures is used offshore, depending on size and water depth. In the last few years, we have seen pure sea bottom installations with multiface piping